Hi and welcome to a new part in this series. This is part 9, and in this part we will finish our Vertex Buffer class and hopefully get something on the screen. Okay, let's begin. In our Vertex Buffer.h file, let's add some new private variables and begin by adding a new GL enum underscore mode. This will basically store the driving mode that OpenGL should use for this buffer, so for this object we're drawing now. I'll explain that another time, but yeah. Okay, and the next one will be a GL size, with an I at the end, and you can name this one count. And what this will store is the amount of vertices per mesh. So for instance, a triangle has 3 vertices. So this will be 3. Quite simple. And our last one will also be a GL size, and this will be the stride. What the stride stores is the size of all of the attributes of an object. Okay, then let's add 2 new methods. The first one will be simply, I'm going to call this and just call this void render vertex buffer with no arguments. But the second one will be called, and this will be also a void configure vertex attributes, and for now it will take only one argument, and that will be a GL integer, so GL int, and that will be the vertex position. And I'll explain both of these methods right away. Before I forget, let's add some extra arguments to our constructor. The first one will be GL enum mode. You have to initialize the variables, of course. GL enum mode. Then we also need GL size count and GL size stride. Okay. Now switch to your .cpp file and add the variables here. So GL enum, and again I keep writing it wrong. GL enum mode, GL size count, and GL size stride. Okay, then in your initializer list, let's initialize these variables. So you can simply do underscore mode with mode, underscore count with count, and underscore stride with stride. Okay, then let's implement our first, let's do the easy one, so our render vertex buffer. So simply do void render, sorry, actually void vertex buffer render vertex buffer, and it's only going to have one function, will be GL draw arrays. This is a function that actually draws stuff. It's quite simple actually. The first argument is a mode again. I'll explain the different modes in a future video. For now, you'll actually be using only one, namely GL triangles, but that you'll see later. Then the first, this will always be basically 0. Always. And the count underscore count. So again, this is actually the function that draws stuff. Then our configure vertex buffer function, I mean method. So vertex buffer configure vertex attributes, and it has only one argument, GL int vertex position. Then this will have a couple of arguments. Well, it's kind of more complex. So first up is the if statement. So if vertex position, and that's a bad name actually. Yeah, it's a bad name. I should rename this to handle. Yes. Or actually just give it a vertex position. Come. So if vertex position does not equal -1, now you want to do GL enable vertex attribute array vertex position and GL vertex attribute pointer. Again, the first argument will be vertex position. Our size will be 3. Our type will be GL underscore float. GL false. The stride will be stride. And for now, this will be, the offset will be null. Now to explain this, basically last video we defined in our shader we made a variable for our vertex position, and then we made like a pointer to it, but to that location. But now we have to enable that location, and we enable that location with this first function, and then we actually have to explain what the data will look like. So here we basically dealt that the data for our vertex text position will be a GL float consisting of three values, and it will be so big, and the offset will be this. Now for this I'll explain. So the stride and the offset I'll explain in another video. But for now, just ignore it for now. And this normalize is basically always false. You can ignore this. Okay, and that was our vertex buffer. Now switch to your render system.h file, and we'll only do two things here. First, we will include our Vertex Buffer.h class, and we will simply create in our render. For now, we will make here a Vertex Buffer pointer argument. Later, we'll remove this with something else, but for now, it will be a Vertex Buffer. Before I forget, also let's include one more thing, namely the vector class. So vector, which is a standard library class, and that was basically great. And I'm not sure how we'll do this, but for now let's simply create a private, so std vector, and also quickly let's include our shader interface.h. Yes, and now do std vector, and we will do this with the shader interface pointer, of course. So pointer to a pointer, and this will be a pointer to the shader array, which will store all of the shaders. We'll probably make a resource class later on, and we'll move this to there. Yes, okay. Okay, now let's switch to our CVP class. Before I forget, quickly define glf include glue, which will include an additional library with or include w line there. Okay. Now in .cpp, let's add quickly here Vertex Buffer. Okay. Then in your constructor, let's do a couple of things. First of all, let's initialize std vector. So shader array equals new shader equals new vector. Sorry, equals new std vector shader interface. Shader interface. Yes. Okay. If you don't know what this is a C++ feature. It's a template. It will basically this allows us to use this container, so the vector for any class. If you didn't know that, and here we say for what kind of type we will use it. So in our case, the shader interface pointer. Then at the moment you only have one shader, so this could actually be kind of ugly, but yeah, no problem. Shader interface equals new shader, and this will be our color shader. Don't have to color, actually just do shader, doesn't matter at all. Shader, new shader interface, and we now have to provide our actual shader. So color, string color shader dot bsh and color and the string and our color shader dot fsh. Okay, and it is giving me an error. That's no problem. Then yes, I'll fix this later, no problem. And then simply do shader array pushback, and let's push back our new shader, and this will basically add this shader to the array. And in here, let's simply do let's simply then do delete this like a really simple version of this for now. Let's simply do shader array and then do add. This will be at 0 basically for now, just to clean this up, and also then delete our shader array itself. So shader array. So this is simply the cleanup code. So here we delete our actual shader, and then we delete our array itself. Then I won't explain all of this, but for now just do this GL load identity. Now glue lookup, and I'll explain this later, but for now just do simply the first one will be 00f, the second one will also be 00f, then this will be do like -5.0f, then all of this will be 0f, 0f. This and the one before the last one will be 1.0f, and the last one will also be 0f. To explain this in very simple, this resets all the transformations, and this is kind of our camera function, if that makes sense. Yeah, okay, hopefully it did. Then a Vertex Buffer, and vertex buffer, and for now, let's first do configure vertex attributes and our vertex position now. This should technically be 0. And you know what, let's do 0 for now. It will be 0 because we only have 1 at the moment, so it almost certainly will be 0. Let's keep it at 0 for now. Yeah, like this is not final code, of course. And then let's also do a vertex buffer draw. Was it or render vertex buffer? Yes. Okay. Then and actually let's do this in this in our get render system. Do GL matrix mode GL underscore projection. This switches the current matrix to the projection one, which basically defines the coordinate system of OpenGL. And what I want you to do is quite simply do glue perspective, and then this first line basically says what the field of view is. Let's say it's 65.0 f, which basically means 65 degrees is a common number for this. Then our aspect ratio, so the aspect of our screen. This is not final cut, by the way. Simply do 1280.0 and make sure it's a floating point number. This divided by 720.0 f. And actually, let's make this 75. Like this. Then the near, so the near plane will be 1 and the far plane will be 1000. This is basically like the coordinates. So yeah, so the farther we go, the bigger the z value becomes in our coordinates system. So we basically define our near and our far plane, which I'll explain later again. Yeah, sorry for that. I keep telling you I'll explain it later. And one more method maybe, GL viewport, not necessary, but simply do 0.0 f, 0.0 f, and 1280.0 f and 720.0 f. And then switch the matrix mode back to it's the default matrix mode is actually at GL model view, like this. Okay. Quickly change over to your shader interface .h and change this from char to constant char. So constant, and also your load text from file also to constant char pointer. Also make sure to update those methods in the shader interface.cpp file. And finally, in your game manager.h, this will be temporarily code. Make sure to simply create a temporary variable, namely a vertex buffer pointer to the vertex buffer. Okay. Now quickly let's in our game manager.h, let's quickly create some very messy code. So above our constructor, do GL int, or do GL float, would be better. GL float, and name this basically vertices. As vertices, and this will be an array, and it will be a very simple array. This will basically define all of our vertices. Now I will explain how the coordinate system works in depth later, but for now simply use these, and I'll simply type them out. So simply copy this. These are basically the coordinates for a triangle. It's quite simple actually. So this is the bottom left vertex, this is the bottom right vertex, and this is the top middle vertex. Notice like these two are put minus. Here we switch to the right. So the x1, so this x, y, and z. This one is plus, and this is still minus. And this is 0 because we're in the middle now, and this one is now plus, and z is always 0 for now. Then our vertex buffer, which is an underscore, doesn't matter now. So vertex buffer equals new vertex buffer, and the arguments are, so the first one is simply our data, then the size of our data, so simply use size of data, which will give the size in bytes. Then the mode will be GL triangles. The count will be 3. And the stride will be, so the size of a single vertex and its attributes is, and R has only one attribute, namely the position. Simply do the size of GL float multiplied by 3. And that's our vertex buffer. Okay, then simply then add it here. Vertex buffer. Oops. Vertex buffer. Okay. And it's an error. Oh yeah, of course. Data. Damn it. Vertices and vertices. Now this won't work just yet, at least on Xcode. You do this if you are using Xcode. Go to your project manager, targets, select your simple FPS target, build phases, and copy files. Change this to products directory. Remove the subpath. Uncheck this, and then add your 2 shaders. So this will add our shaders to our project when it is running. Okay. Also make sure it's not in the compile sources. So remove it from the compile sources if it was there. Alright. First off, remove this last comma here. So before we run this, there's a problem with making code that doesn't actually do anything. Because now for multiple episodes, our code didn't actually do anything yet. It was incomplete, and because of that, I actually left some mistakes. So let's correct them now quickly. So first of all, this is a vector tree. So we are now in the vertex shader. This is a vector tree, but this is a matrix 4, and we can multiply a matrix 4 with a vector tree. So to fix that, we should basically do this vec4, and the last argument will be 0, 0, basically. So now we actually take this vector tree and add 1 to it and make it a vector 4, basically. It's that simple. The reason we have to do this, yeah, well, if you know matrix math, it's a math thing. And this one is again a math thing. This is basically always 1. If it's a 0, it's basically a point, and if it's a 1, it's a direction, and we want a direction, not a point. Yeah, it's quite. If you know math, this should be quite clear to you. Otherwise, don't bother. Now, in your render system, we forgot 2 crucial things. I'm sorry. First of all, we have to actually use the program. So type GL use program, and we only have one, so simply say program 1. We'll modify this later, of course. And also let's do this. Let's do gel uniform 4f, and the location will be 0 because we only have one. Like, this is like temporary code, by the way. And we'll do and then our colors. So this will set. So this gel uniform will actually set the U color vector 4 in our color shader, in our fragment shader. And here we simply define our colors. So say we want a red triangle. You 0, F, 1F, and the last one will be. So essentially the first is 1 because we want full red intensity and 0 green and blue intensity. Okay, so now if we run this, we get a red triangle. I hope you can see this. A red triangle. Now, if we change this to say 1 also, we'll get a different triangle. We'll get a yellow triangle this time. So yeah. Okay, this was a long episode. Tomorrow, so the next few episodes we'll basically do some cleanup stuff and make this a little bit prettier to look at. After that, I'll make a video explaining these two functions more in depth, and then we'll make a lighting shader, so which kind of acts like a light, and we will move from there. Then we'll also make a movement system, a scene system. We'll begin using an entity class. We'll make a camera class, and so on. So it will be So now for the first time we actually got something on screen. It's not much, but it's a beginning. So we're off to a good start now. Okay, see you next time. Bye.